Everybody can see that?
Yes.
Okay. So obviously this is a founders meeting that we've been wanting to have for a period of time now. We originally discussed oscillating isometric muscle actions as a new, a quote unquote new type of isometric, maybe about a year or so ago on the Substack. We described sort of what they are, what they're intended to do, how we can use them, the performance of them, et cetera, et cetera. The purpose of this meeting, I think, is to really just go into a little bit more detail. I think over the course of the last year, we've refined the oscillating isometric muscle action. We've added some detail, provided a little bit more, or thought about providing a little bit more framework behind them, so that we can really truly understand what they are designed to do, how they fit into the capacity of reactive strength, how they can be used both from a bottom-up perspective and a top-down perspective, and we'll get into all these things as we go. So I think we just wanted to present this information so that everybody kind of has that framework. In the end, obviously that is going to influence the performance of oscillating isometric muscle actions. So now we can be a little bit more specific in how we perform them. And then obviously that leads to programming, and that means that we can be a little bit more knowledgeable and specific as to how we would program them for acquiring certain components of reactive strength, whether that be bottom up or top down. In saying all that, we do have to kind of go through these concepts of resonance and damping. I think I'll keep obviously those very short. They are physics concepts. There's a bunch of physics information that we will leave out, but the gist of what those are will really, those are the theories of resonance, and the theory of damping is what's going to actually allow us to understand the oscillation and the isometric component of the oscillating isometric muscle action in that detail that allows us to be a little bit more specific. Just to review very quick, so the first part of this presentation is just a little bit of a review. We've discussed this on Substack as well, just the different types of isometric muscle actions. So the reason I'm reviewing this is because as we go through this presentation, you will see as we get to the performance of the oscillatory isometric muscle action that there is going to be components of at least two of these in every oscillating input that we do. So that will kind of become apparent as we kind of get through the information and get to the end. But the performance of the oscillatory isometric muscle action, which is kind of our addition to the types of isometrics, will involve either a pushing or a holding, depending upon whether we are trying to go top down or bottom up. Okay. So quick review: holding isometric muscle action, pushing or pulling isometric muscle action. I didn't put in here the isometric continuum that we have published on Absolute Substack as well, but that does kind of hold true. Probably should have included that. So the holding isometric muscle action, or the yielding, obviously is going to be submaximal for the most part, and that is going to be our definition of what a bottom-up isometric muscle action would be, where you're going to hold a particular angle or that eventually over time would yield, and in that yielding you would influence more of the connective tissues. Okay. Obviously, on the other end of that continuum is the pushing or pulling, which is more neurological based. These are going to be 75% effort or higher as a general rule, 75 to 80% effort or higher as a general rule, and this is going to constrain the nervous system. So this is going to be our top-down isometric muscle action. Okay, and then the oscillation as I said, involves a combination of the other two with some external force of oscillation. Okay, and then you're going to either have to yield into it or you're going to have to push or pull your way through it. At any point in time, for anyone in attendance here, you guys can stop me and ask any questions. Okay, so why do we use oscillatory isometrics? And what are they? So what is an oscillatory isometric? So again, this is a review from our Substack. We originally posted this article with Jim Seitzer doing the introduction and the use of oscillating barbells. So they do involve the use of an oscillating load that can be a barbell plus or minus any external load. And whatever that external load might be, dumbbell, kettlebell, attached through some sort of oscillatory mechanism. And the idea is to create a continuous wave-like force during the movement. So if you think about oscillation, and again, we'll go into some detail, not a ton of detail, but if you think of what oscillation is, it's just a wave. So like a typical sine wave is what oscillation would be. So it's just movement back and forth, back and forth. If you think of like a wave in the ocean, it kind of goes up and down, up and down. So there's movement back and forth at sort of a continuous frequency or like a symmetrical amount, both up and down, okay, for a period of time. So that's what oscillation is. So you can get that oscillation through the barbell. So if you're using a particular barbell that does oscillate, obviously with load on the end of the barbell will move up and down, creating a wave-like force that the trainee will have to mitigate against. Okay. If you add external load through a vibrational or oscillating mechanism like a band, it's going to be the same scenario whereby the weight at the end of the band will move up and down or back and forth, creating this wave-like force that the lifter or the trainee will have to mitigate against. So that is the general um, theory behind oscillatory isometric muscle actions, is to create this wave-like force that the lifter will ultimately have to mitigate either using bottom-up or top-down mechanisms. Okay. So initially we discussed oscillatory isometrics with respect to the biological network of connective tissue. And this is where we will get in a little bit more detail in this presentation. And this is perhaps where we at Absolute have added on to the framework a little bit. As I said, we originally thought of these as being more bottom up and in using that wave-like force that is then going to have to be dissipated over time to create a time-based stimulus for the connective tissue that ultimately the connective tissue is going to have to buttress over a period of time. Okay. But now in the use of oscillatory isometrics with respect to reactive strength, we're going to move forward a little bit and see them from both a bottom up and a top down perspective. Okay.